Hello guys, welcome back to my YouTube channel. This is Jason Bibilan aka Organism118 and welcome to this episode of Learning Biochemistry. Okay, so last videos about biochemistry, I talked about the biologically important monosaccharides. And for today's lesson, I will be talking about biologically important disaccharides. Okay, so recall that the disaccharides consist of two monosaccharides that are actually joined together by an oxygen bridge. Okay? In biological systems, monosaccharides exist in the cyclic form, and as we have seen, they are actually hemiacetals or hemiketals. Okay, remember that your hemiacetals are formed whenever there is an aldehyde reacted with an alcohol. Okay, and hemiketals are formed when a ketone is reacted with an alcohol. Okay, so recall that when an hemiacetal reacts with an alcohol, the product is an acetal. Okay, and when an hemiketal reacts with an alcohol, the product is a ketal. Okay, in the case of disaccharides, the alcohol comes from a second monosaccharide. Okay, because remember that your monosaccharides are already been formed because of the formation of hemiacetals or hemiketals. Okay, because of the your monosaccharides become cyclic because of the reactions that form hemiacetals or hemiketals. Okay, so if you have another uh, monosaccharides that will link with that monosaccharides, you will form a disaccharide. So that your hemiacetals, okay, the first monosaccharide, which is a hemiacetal or hemiketal, will react with another monosaccharide. Okay, that second monosaccharide will be they will have the OH group on its structure, and that will function as an alcohol that will react to the first monosaccharide or the hemiacetal or the hemiketal. Okay, then it will now form a ketal or an acetal. Okay, so in the case of disaccharides, the alcohol comes from a second monosaccharide. The acetals or ketals form are given the general name glycosides. Okay, so disaccharides are already been named as glycosides. Okay, they are glycosides now. And the carbon-oxygen bonds that link between those two monosaccharides are what we call the glycosidic linkages. Okay, so disaccharides, as we have learned, that it consists of two monosaccharides that are linked together by the oxygen bridge or what we call the glycosidic bond or linkage. Okay, so glycosidic bond formation is non-specific. That is, it can occur between a hemiacetal or a hemiketal at any of the hydroxyl groups on the second monosaccharide. Okay, so it's any on the hydroxyl groups of the on the second monosaccharide. Okay, so that is a glycosidic bond. It's non-specific. Okay, it can occur any of the hydroxyl groups at the second monosaccharide. Whenever you have your hemiacetal already on the or the first monosaccharide, okay, so it can bond to another hydroxyl group of the second monosaccharide at any hydroxyl groups found in the second monosaccharide. However, in biological systems, we commonly see only particular disaccharides. Okay, so this we will only discuss the three common disaccharides that we can see in biological systems. Okay, these specific disaccharides are produced in cells because the reactions are catalyzed by enzymes, and each enzyme catalyzes the synthesis of one specific disaccharide, ensuring that one particular pair of hydroxyl groups on the reacting monosaccharides participates in glycosidic bond formation. Okay, so what are these three common disaccharides? Okay, number one is we have the maltose, number two is sucrose, and number three is the lactose. Okay, so first we're going to discuss about maltose. So what is maltose? So maltose is a disaccharide that is the combination of uh, two monosaccharides, which is an alpha D glucose or another second glucose unit. Okay, so if an alpha D glucose and a second glucose are linked, a disaccharide maltose is formed. So maltose is also commonly named as malt sugar. Okay, so this is one of the intermediates in the hydrolysis of starch. Okay, because the C1 hydroxyl group of an alpha D glucose is attached to the C4 of another glucose molecule, then the disaccharides are linked together by an alpha 1,4 glycosidic bond. Okay, so your maltose is basically an intermediate on the hydrolysis of starch, and it is also called as a malt sugar. And the link between the alpha D glucose and the second glucose is that your carbon number 1 and the alpha D glucose is linked with a OH or hydroxyl group in the carbon number 4 of the second glucose. Then the link between those two monosaccharides are what we call the alpha 1,4 glycosidic bond. Okay, so maltose is actually a reducing sugar because the second glucose that is actually linked on the first glucose has a reducing end that is found on its carbon number 1. Okay, so there is an anomeric carbon on the second glucose, and therefore your maltose can be is susceptible for an oxidation. Okay, so therefore it is a reducing sugar. Okay, because it has a hemiacetal hydroxyl group or a free OH group found at the C1. Okay, and this is because the cyclic structure can open at this position in a C1 to form a free aldehyde, and therefore it could be oxidized by an oxidizing. If there is an oxidizing agent, then therefore this sugar maltose can be oxidized. Okay, so that is the main features for maltose, and most especially maltose. You can see it. This is a malt sugar. Okay, so uh, this actually the maltose is also used in the beer industry. Okay, because they are the ones that being fermented to form or to produce an alcohol that is found or that will be used in beer production. Okay, so this is now the chemical reaction or the reactions of two monosaccharides. You have your alpha D glucose plus your beta D glucose, that is your second glucose, to form now your maltose. Okay, so as you can see that the carbon number 1 of the alpha D glucose is actually linked with the carbon number 4 of the second glucose. Okay, and both of this and the first monosaccharide is actually on its alpha position. Okay, that is alpha D glucose, so that your alpha 1 form will form alpha 1,4 will form the glycosidic linkage between these two monosaccharides. Okay, so as you can see that in the carbon number 1 of the second glucose is what we call the anomeric carbon, and it is free OH hydroxyl there. Okay, so that this is reducing end. Okay, so no, your maltose now has its own reducing end, so therefore it is a reducing sugar. Okay, uh, because of the C1 here or the anomeric carbon there. Okay, so basically if you have alpha D glucose plus your beta D glucose, you can actually form a beta or a maltose. Okay, so how do you name this disaccharide? Okay, you can name disaccharides by first name it as you name first the non-reducing sugar. Okay, so between these two monosaccharide, which one is non-reducing sugar or non-reducing monosaccharide? Of course, the first one. Okay, so you name this first, then followed by the second sugar. Okay, so you name first the non-reducing monosaccharide, and after that the reducing or the second monosaccharide. Okay, so since the name is of this sugar is alpha D glucose, but it is actually on its what? It is a pyranose. Okay, so it's a pyranose because it's a six-membered ring. And remember, disaccharides are glycosides, so therefore we are going to end the the name of the disaccharide with the side or ide or IDE to to justify that the disaccharide is in a glycoside form because of the glycosidic bond. Okay, so you name first uh, the non-reducing monosaccharide. Okay, you name this first. So the first sugar there is alpha. Okay, that is alpha D. Okay, alpha D, gluco, okay, glucoperanose. But since this is not the final name of this disaccharide, so you can say that it is pyranosyl. Okay, so if it is a six-member drink, it becomes a pyranosyl. Okay, so if it is five-member drink, then that becomes furanosyl. Okay, so this is glucoperanosyl, so alpha D glucoperanosyl, and you indicate the linkage that is actually 1 to 4. Okay, so you indicate the linkage. Then the last name would be your the second sugar, okay, which is actually a beta, okay, beta D, that is gluco, okay, gluco, pira, okay, so it is not now peranose, okay, because it is a glycoside, so that becomes a peranoside, okay, peranoside, that is uh, IDE. Okay, so just bear with the spelling there. Okay, so the name of this disaccharide now is what we call the alpha D glucoperanosyl, and the linkage is alpha 1,4. Okay, then beta D glucoperonoside. Okay, so that is the name or the systematic name of the disaccharide maltose. Okay, now let's move to the second disaccharide. Okay, so the second disaccharide is what we call the lactose. So lactose is actually a milk sugar, and it is a combination of the beta D, alpha or beta D glucose plus it's the combination of the beta D galactose. This is the first sugar plus the alpha or beta D glucose. So it depends if it is an alpha or a beta D glucose. Okay, so that is the second sugar. So galactose differs from glucose only in the configuration of the hydroxyl group. Okay, so we knew that already, that galactose is different from the glucose. Okay, and the linkage or the bonds are between the beta D-galactose and the D-glucose for these disaccharides actually linked by a beta 1,4 glycosidic bonds. Okay, so as we can see now on this figure, if you have the beta D-galactose, okay, if you have beta D-galactose here, this is beta D-galactose, and you have your beta D-glucose are linked together, you can now form your lactose. Okay, they are actually linked with the beta 1,4 glycosidic bonds. Okay, so what would be the systematic name of the beta lactose? And remember, your lactose has also a reducing end. Okay, this is a reducing end of uh, the lactose. Okay, so if you're going to name this disaccharide, you take note that you name first the non-reducing end. That means this one. This is your beta D galactose. Okay, so the name would now be, you have beta D. Okay, beta D galacto. Okay, galacto galactoperanosyl. Okay, so galactoperanosyl, not galactoperanose, but peranosyl. Okay, galactoperanosyl. Then what is the linkage? That is 1,4. Okay, then the last one is you have your beta D glucose. Okay, so beta D uh, glucoperonoside. Okay, so this becomes glucoperonoside. Okay, so it should end with an O side or side. Okay, or IDE. Okay, signifies that your disaccharide is a glycoside. So the IUPAC naming for this disaccharide will now be beta-D-galactopyranosyl, linked by a beta-1 for linkage with the beta-D-glucopyranoside. Okay? Okay, so lactose is the principal sugar that is actually found in milk for most of mammals. Okay, to be used by the body as an energy source, and lactose to be used by the body as an energy source. So lactose must be hydrolyzed first to produce glucose and galactose. Okay, so in order for lactose to be used by the body, so we need the enzyme lactase in order for the glucose to be hydrolyzed, okay, to form now the D-galactose and D-glucose, okay? And your D-glucose is absorbed by the body because this one is, the body is used this for energy because the primary source of our energy is the D-glucose, while your D-galactose needs to be converted first into a D-glucose, okay, by different enzymes, okay? So it needs to be converted, your D-glucose first needs to be converted into into D-glucose by the different types of enzymes, okay? So that if uh, D-glucose now can be converted into D-galactose now can be converted into D-glucose, then that's the time that it will be used by the body. Okay, so some of the children or even adults doesn't have their lactase, or they have no enzyme lactase on their stomach, okay? So on their stomach, so they cannot hydrolyze if they have lactose. So that's why if you are going to drink milk and if you have this kind of condition called lactose intolerance, you will be feel uneasy with your stomach, okay? Your stomach will get hurt, or even you can have a diarrhea, okay? Because you have no enzyme lactase in your stomach, and therefore you cannot uh, digest or hydrolyze the lactose. You cannot metabolize, or you cannot digest or hydrolyze the lactose to form it with D-galactose or D-glucose, because you lack the enzyme, or there is the absence of enzyme lactase in your stomach, okay? So that is what we call lactose intolerance, okay? So you don't have a enzyme lactase, and therefore you cannot uh, hydrolyze lactose to be formed D-galactose and D-glucose. Okay, so as what I have said, your D-galactose now, after it will be after lactose is hydrolyzed with the enzyme lactase to form D-galactose and D-glucose, your D-galactose will also undergo a reaction in the body with different enzymes, okay, to form your D-glucose, because D-galactose will not be recognized inside our body, okay, because our primary source of energy is only D-glucose. So that's it. And the body needs to convert the galactose first to D-glucose in order for this to be absorbed or to be used up by the body. Okay. So however, if you don't have the enough enzymes to convert D-galactose to D-glucose, then you have the condition of what we call the galactosemia. Okay, so galactosemia is actually a genetic disease caused by the absence of enzymes needed to convert galactose to glucose. So with these reactions, your galactose in the body is actually converted into glucose uh, by this enzymes. Okay, you have your galactokinase. Okay, your galactose will now be formed galactose 1 phosphate by galactokinase enzyme, and your galactose 1 phosphate can be converted into UDP glucose or glucose 1 phosphate by or UDP galactose by this enzyme here, which is what we call the galactose 1 phosphate uridyl transferase. Okay, so if you don't have this kind of enzymes in your body, then probably you have the genetic disease called the galactosemia. Okay, so in humans, the genetic disease galactosemia is caused by the absence of one or more of the enzymes needed for this conversion. So toxic compound formed from galactose accumulates in people who suffer from galactosemia. Okay? If the condition is not treated, galactosemia leads to severe mental retardation, cataracts, and early death. However, the effects of this disease can be avoided entirely by providing galactosemic infants with a diet that does not contain galactose. Okay? Such a diet, of course, cannot contain lactose and therefore must contain no milk or milk products. So if you have this condition, you should not take dairy products or milk products, okay? So it's very sad for an infant if that infant has this genetic disease called galactosemia, okay? So that's it for lactose, okay? Now let's move to the sucrose. Okay, now let's move to the sucrose. So sucrose is also known as the table sugar or cane sugar, or it's also called as beet sugar. Okay, sucrose is an important carbohydrate in plants because it is water soluble and it can be transported through the circulatory system of the plants. Okay, so animals cannot synthesize sucrose in their bodies, of course, and we humans cannot also synthesize. So high concentration of sucrose produce high osmotic pressure, which inhibits the growth of microorganisms, and therefore your sucrose can be used as a preservatives, okay, and also as a sweetener. And the sucrose is uh, the combination, if you go to the structural formation of the sucrose, it's actually the combination of alpha D glucose and beta D fructose, okay, which are actually linked together by alpha 1 in alpha D glucose and beta 4 in beta D fructose, okay. So what is the structural formation? Okay, so if you have your alpha D glucose here, so this is your alpha D glucose, okay, link with your beta fructose, okay? So you can now form the sucrose. They're actually linked the beta, with the alpha 1, okay, alpha 1 and the alpha D glucose, and your beta 2 and beta D glucose, okay? So this is carbon number 2 and the beta D fructose of that sugar, okay? So so that you can form the alpha 1 beta 2 linkage, okay? So the systematic name of your sucrose is you have your alpha, okay? What is this? Alpha D glucoperanose, okay? Glucoperanosyl, I mean. So peranosyl, okay? Then you indicate the linkage, that is alpha 1 to beta 2, okay, alpha 1 to beta 2. Then you have your beta, okay, this is beta D fructo. So what is this? Fructo, what glycoside? Fructofuranoside. Okay, so this becomes fructofuranoside because remember it is only 5-membered ring. So that becomes fructofuranoside. Okay. So this is now the systematic name of the sucrose. It is actually alpha D glucopyranosyl link with alpha 1 to beta 2, beta D fructofuranoside.